Hello everyone. It's my pleasure to welcome you to today's webinar covering an extremely topical subject, Getting Cloud Encryption Right, Critical Insights to Securing Information in the Cloud. My name is Jerry Grealish, and I'm the VP of Marketing at PerspecSys, and I'll be your moderator today. Before we start, I just wanted to share a few housekeeping details. First, this presentation is being recorded, and all attendees will receive an email following the event with a link to download the slides and access the recording. If you do have questions throughout the presentation, please enter them into the questions box on your screen, and we'll get the answers at the end of this session. Any questions we don't get to in the presentation will be answered by one of our featured speakers offline. Lastly, it may be easier to view the presentation if you maximize your screens. You can do this by clicking on the icon in the upper right corner of the GoToWebinar window. For today's agenda, we'll be starting with a summary of some of the major cloud security concerns as informed by relevant research conducted by the Cloud Security Alliance. From there, we will explore the role that encryption can take in securing sensitive data in the cloud. We'll then identify some of the major issues that need to be considered when an organization is contemplating deploying encryption, particularly at the SaaS layer. Lastly, we're going to touch on some technologies that are being used to help enterprises overcome these challenges. As key takeaways from today's session, we hope to shed some light on the major security concerns that organizations have regarding cloud computing. As part of a layered security approach, you'll see how field-level encryption can be used to address many of these concerns. And you'll understand that techniques and approaches should be vetted to ensure they meet your organization's requirements for encryption strength and interoperability with your cloud applications. At this point, I'd like to introduce our first featured speaker, John Howie, Chief Operating Officer of the Cloud Security Alliance. John has over 20 years of experience working in information technology across a variety of industry sectors. Prior to joining the Cloud Security Alliance, John managed the groups responsible for security in the data centers of a leading cloud provider. He is a visiting professor at Edinburgh Napier University's School of Computing, as well as the University of Arizona Eller School of Management. He's also a member of the editorial advisory board for the Journal of Information Management and Computer Security, and an advisor to the United Nations Interregional Crime and Justice Research Institute's Security Counterterrorism Laboratory. As John is kicking off his section, he'll give a brief overview of the Cloud Security Alliance. Over to you, John.
Yeah, thank you. Thank you very much, Jerry, and it's a pleasure to be here today to be part of this webinar. Next slide, please. So just a quick introduction about the Cloud Security Alliance and who we are and our role in the industry and how we work with our industry partners such as Voltage and PerspecSys. We are a global not-for-profit organization. That's very important. We don't, we're not a business, we're not a for-profit business, and all the revenue that we receive worldwide goes back into producing educational materials designed for use by enterprise users of cloud computing and by small and mid-sized business as well. The focus of our research is really building security best practices for use by enterprises looking at the next generation of information technology, which is today the cloud. The cloud in the last 5 years has massively exploded, and everyone is looking to it. And I always say in these events and in conferences that virtually every organization in the world today of size is using the cloud, whether or not they actually realize it. And so we produce the research and the educational programs designed to help organizations move to the cloud in a safe and reliable fashion. And we candidly rely on the subject matter experts and the participation of organizations such as Voltage and PerspecSys in order to help us actually identify the root issues that enterprise users of the cloud are facing, both before adopting cloud computing and getting into the cloud. So we are hopefully going to be, now and in the future, the authoritative source for trust in the cloud. Next slide, please. Next slide, please. So some fast facts. We are a relatively young organization. We were founded in 2009. Today we boast over 45,000 individual members. We have 66 chapters globally. We have over 150 corporate members. And those span pretty much every industry sector and also the public sector and academia as well. We have offices in Seattle, in Singapore, in Greece, and we have legal entities throughout the world which help us operate and retain staff and manage our research programs. Currently, we have over 30 active research projects and 25 working groups, and we build strategic partners with government, with institutions doing research and development, professional associations, and of course the industry. Next slide, please. The impact of our research is actually gone much further than we originally envisioned. Our first document was something called the Security Guidance for Critical Areas of Focus in Cloud Computing, version 1. That was released at RSA in 2010. And we're now in our fourth version, version 3. We released version 1, version 2, 2.1, and now version 3. And that document really is the starting point for enterprise consumers looking to the cloud for areas of focus, things that they have to be concerned about. Since then, we've massively expanded our research portfolio, and we're developing new research all the time. But as we develop and expand that research portfolio, the impact of that has grown too. And this diagram just shows some of the work that we're doing in some of the organizations and the industry partners, the academic and public sector partners that we have. We're not a standards development organization, but all of our intellectual property is offered to the standards bodies so that they may actually consider it as intellectual property for inclusion in standards. Very importantly, all of our research, all of our guidance, all of our tools is available on our website for free of charge. We do not charge for it. You can download it. And that includes commercial reuse. We do not charge for commercial reuse. So if you like some of our intellectual property and you think it can help you in your business, feel free to download it and to use it. One of the working groups that we have is the Threat Research Working Group. We formed this working group in 2009 to look at the emerging threats to cloud computing and also the threats which are preventing people from moving into the cloud, threats that they couldn't mitigate the risk from. We initially released a report called the 7 Deadly Sins. We then released additional reports focusing on big data and mobile computing. And we went back to the 7 Deadly Sins, the original threat research report that we released, and we published that in February of this year at the CSA Summit, the RSA conference. And basically it was just an update to the original report that we released a few years back, but we also took the time to map it to our other areas of research and guidance and tools. And so we're going to take a look at that, and we're going to set the stage for the rest of the webinar. If you look at the results of the research report, and what we did was we sent out a survey globally. We made sure there was representation geographically and across industry sectors, from IT pros, from technical and business decision makers, and from experts in academia and in government. And the top 2 issues today that we see which are causing barriers for adoption to the cloud are data breaches and data loss. And I want to make a distinction between them. And let's start with data loss. Data loss is where the data is corrupted or destroyed and is irretrievable. And so with that in mind, we're not talking about someone dropping a USB thumb drive in a parking lot with data on it. That data loss is the destruction or the other loss of data which cannot be retrieved. A data breach, on the other hand, is where data is leaked out of the controlled environment, either on-premise or your cloud provider's facilities. And this is the one that we really want to concentrate on right now, because data breaches are one of the single greatest headaches for organizations today. Whether it is data which has been lost because it's on a laptop or a mobile device, or data that was on a thumb drive or a portable hard drive which is being stolen or dropped or left at the airport security line, or whether it is someone who's got access to your cloud service, either a current or former employee, or a malicious bad actor who's got access to your data in the cloud, and they've compromised and got access to that data, compromised the security, got access to the data, you may now be required to report that under a variety of data breach notification laws which exist worldwide. And so this really is one of the core issues that enterprises are facing today. One of the top threats to cloud computing is a data breach. The good news is that there are solutions which can actually help you protect your data in the cloud, and encryption is, of course, the one that we're going to be focusing on today. So data breach is the current #1 identified threat to cloud computing by the people that we surveyed. We gathered all the research, and this clearly stood out. It actually moved up from #5 in the 2010 report to the #1 issue that companies are facing today. Next slide, please. And we see other threats as well. Here are the last 5 that people identified. And there are also options here as well for utilizing encryption to protect data. For example, malicious insiders within your organization, people that may have access to systems or data and abuse that access. By using encryption and controlling who has access to the encryption keys, you can actually defeat the malicious insider as well. So encryption is not just about protecting your data from a breach. It can be used very tactically and strategically in other areas of cloud computing as well. Also, shared technology vulnerabilities where you might be running in an infrastructure as a service environment and you're concerned about what happens when another user of the service is able to potentially get access to your data, either because you misconfigured security controls or because of a vulnerability in the provider's infrastructure. I do want to point out that there's no reason to believe that providers do have these vulnerabilities, but it is a perception issue that if my data is co-located with someone else's data, can they get access to it if the provider does something wrong? Again, encryption can be used. In this context, I do want to point out that a recent report showed that in a survey of people using a block storage service of a very large cloud provider, the bulk of the data stored on there was actually unencrypted. There was no controls on there, and anyone could access that content. And so encryption is just one of many things that you should be doing, including setting up access controls appropriately. But if everything else fails, encryption can protect your data. Next slide, please. So as I said, we took the time in this release to actually map this to our security guidance. The security guidance, as I mentioned earlier, is in version 3. And you will notice that we do actually have 14 domains, and one of them is encryption and key management. And I do recommend that you take the time to download the security guidance for critical areas of focus of cloud computing, because it's a wonderful resource, and you can use some of the best practices that we've outlined in this document to help protect your use of cloud services. Next slide, please. And lastly, before I hand it over to Jerry for the rest of the webinar, I do want to highlight that we've got some intellectual property called Security as a Service. This intellectual property can also be used in conjunction with the top threats research and with the critical areas of focus of cloud computing, the security guidance version 3, to further secure your use of the cloud by using what we call Security as a Service, which is a series of best practice and recommendations and tool sets which are cloud-based, which you can utilize in order to protect yourself and to protect your data. So with that, I'll hand it back to Jerry, and I will be available later on for any questions. Jerry, back to you.
Thanks, John. I think John's comments set an excellent foundation for the next section of the webinar. At this point, I'd like to introduce our second featured speaker, Jeremy Stieglitz from Voltage Security. Voltage Security is a leader in data-centric security, delivering secure data-centric encryption and key management solutions, enabling enterprises to combat new and emerging security threats. Jeremy has over 20 years of experience defining product platforms and partnerships, and is author of 18 patents in network security, user authentication, and network automation. As VP of Business Development for Voltage, he drives its strategic partnerships with technology partners. Jeremy has led product management, marketing, and BD at companies such as Force 10, Cisco, and RSA. Jeremy, over to you.
Thanks, Jerry. Next slide, please. So we're all here today because cloud-based IT is accelerating in the enterprise today. It's driven by simple economics and really the ability to do more faster and the consolidation afforded by the cloud. Of course, moving enterprise assets, enterprise data to the cloud requires new security concepts, tools, and approaches. So we're going to talk today about a data-centric security approach for clouds. And by going data-centric, we hope to achieve the following. give enterprises a control point back in the ability for the enterprise to control data as it sits in public clouds or SaaS clouds, managed, operated, and run by others. But at the same time, we want it to be non-blocking. We want this security to fit within the applications and capabilities that the cloud offers. So you're moving your assets to the cloud so that you can be dynamic and mobile and accessible, and that you can have the advanced features of things like Salesforce search or keywording or tagging or indexing. We want security to be non-blocking to that operation. And by non-blocking, I mean fits within the business processes that you need from the cloud. So we'll take a look at a balancing act between owning the control and staying within the agility and scalability offered by the cloud. And of course, as John mentions, security fundamentally is there to protect against breaches and attacks, as well as meet, match, and surpass the compliance requirements if you're putting personal information, healthcare information, PCI information into public or SaaS-based clouds. So let's take a look at a new security approach matched to the requirements that we've just laid out. You know, we get asked a lot at Voltage, are we encryption at rest or encryption in transit? And in some ways, I think they're asking the wrong question. But we've come up with a model to talk about where you can apply encryption and some of the trade-offs between those. And we call this the sort of IT infrastructure stack. And moving from the bottom to the top, you can apply encryption at various levels of your IT stack. You can attack this problem at the bottom with technologies like full disk encryption. The benefit of attacking things at the bottom of the stack is that they tend to be simpler in operation. You use one encryption, one key, and you make a decision once, and it happens transparently. So if you're encrypting your whole disk on your computer, chances are you don't see that operation. You log in, and it unwraps, and you're good to go. Next slide, please. The challenge with operating things at the bottom is that you have to make information accessible up the stack. And so as you move up from whole disk encryption or database encryption, information passes up this stack in the clear. And so clearly you can see kind of a trade-off here. You've got fewer keys and less disruption to your business applications because information is in the clear as it reaches applications. But you've got a big security trade-off. Every application above sees information in the clear. In fact, we see this in the real world. Some very large breaches and attacks were using encryption. Heartland Payment Systems, which had one of the largest credit card breaches in the history of the world in 2008, was using transparent database encryption while they were getting attacked. They were getting attacked because the attackers were using it at the application layer. So what's the alternative? The alternative is to move up the stack and grab data and lock data at the data level. And that's what we're going to be talking about today from a cloud security standpoint. What would a data-centric, data locking approach require? And we're going to take a look at some of the technical details behind data-centric security. Specifically, application layer data protection to provide seamless end-to-end security down the stack. You encrypt it once at the field level, and you are protected all the way down the stack. If attacked, as John mentioned earlier, with proper encryption, data has no value. And so this is an idea about locking data at the data level and locking it once at the application layer. But we will be mindful of that notion of agility and non-blocking operation to what the business needs. So let's see how we can tackle both of those at the same time. Next slide, please. So if we're going to grab data at the data level, the field level, we're going to have a couple technical requirements that are different than whole disk or transparent disk encryption. One thing, we have to grab data inside a field and lock data in place. Another is that we're going to have more keys. If we're locking data at the individual data level, we're going to have a lot more keys to manage than we would normally under a TDE or one lock for the entire set. And lastly, if we're going to lock data at the data level, we need to be mindful that those locks have to be openable across where your data moves across different applications. Let's cover all of those in more detail next. So the traditional encryption approach, the standard in the industry today, is a cipher called AES. And AES is a cipher that is formatted into blocks. Whatever data you present to it, The result is an encrypted block. On the right-hand side, that starts with a UE. That encrypted block is protected, so it gives you great security, but it tends to break and make challenges inside field-level operations. Specifically, it changes the format of the data, which could require database schema changes. It changes the size of a field, which could increase storage. And it may introduce characters and symbols not recognized in the database. So as we think about locking data in place, we've got a bit of a challenge here. We want to lock data inside an application like Salesforce, but we have to be mindful of the changes that AAS introduces. And so this presents a challenge to locking data in place. How do we take field-level data, lock it, and not have these technical attributes that AAS introduces? Next slide, please. A new technology that was introduced and brought through standardization efforts basically over the last decade is the capability of utilizing AAS in a mode that preserves the field length and format of the data type. And that technology is called FormatPreserving Encryption. FormatPreserving Encryption, as you can see, takes a structured data item, such as a credit card, social security number, driver's license, and can encrypt it in place. What I mean by in place is preserving the same format, same structure, same field length as the starting data. You now have a lock capable of locking fields inside Salesforce without the disruption typically associated with AES. And that ability to lock data also gives you some additional abilities to choose partial encryption. In the example on the left-hand side, the format-preserved encryption of a credit card is actually locking the data by hiding the inner digits, but retaining the bank routing information in the front and the PIN validation to the back. So we actually have a very flexible lock. We can lock data at the field level, preserve formats, and even go inside the field level to define how we want to reveal and protect that information. At the same time, because format-preserving encryption maintains referential integrity, we have this nice attribute that any value put into the locked format is going to consistently stay locked the same way. That can be useful for analytics and other applications that need to have a one-to-one mapping of source data to locked data. Next slide, please. So as we think about SaaS and cloud and challenges behind locking technologies versus non-disruption to business flow and schemas and databases, it's important to think about what type of validation and verification these technologies introduce. This is Gartner on encryption for SaaS. Gartner sees, a lot of clients concerned about the transparency and underlying cryptographic approaches mentioned here. We're talking about format-preserving encryption as a mode of AES. How is it validated? How is it standardized? What are the third-party attestations that prove out its strength? Those are the kind of questions we think the market should be asking when they look at cryptographic approaches inside clouds. What are the relevant standards? What is the transparency behind what is happening here? Next slide, please. And we take that very seriously. Format-preserving encryption, I mentioned, I called it new. That was the wrong thing to say. It's not new. It's been out there for a number of years, peer-reviewed, lots of published papers, lots of independent cryptanalysis. We publish and post all of that cryptanalysis available for the market. We think it's absolutely critical that these methods are transparent, well-advertised, and well-reviewed by the industry and the research community. And that's really step one. Step two is validation, recognition, and industry standardization. And so we've been actively working with the NIST organization inside the U.S. government. And NIST now has a working group that has accepted format-preserving encryption as a working mode of AES. I think it's important to mention that format-preserving encryption incorporates AES and utilizes AES as its underlying cipher. So we're not inventing new ciphers here. We're simply constructing and using AES in such a way that it preserves formats. But the public proceedings of that are all published, and you can look to the NIST working group to see this present standardization effort going on for format preserving encryption. Okay, next slide. So we've got this ability now to lock data in place, but as I mentioned earlier, if you're going to lock data at the data level, you're also going to run into some key management challenges. We just want to take a brief look at a technology that we call stateless key management in order to solve that problem. Stateless key management lets you create keys on the fly from a derived base key. Simply put, if I need to create thousands or millions of keys, I don't have a problem anymore because I don't need to store these keys anymore. By using a key derivation methodology and staying stateless, I now have a very elegant, seamless, distributable, highly available way to manage keys on a global scale. So stateless key management is really part and parcel of this strategy for data-centric security. You can't lock data at the data level and create thousands of keys that have to be replicated and the state managed across different points of presence to keep the system up and running. Next slide, please. So that was really the introduction to data-centric security, an examination of owning control at the enterprise level, locking data at the data level, and having a key framework that can provide consistency across different applications so that different applications can open that data and make work with that data. But really, that's sort of the beginnings of the assignment. Next up, we're going to take a look at how to make encryption work within the context of a cloud application. So now we have an effective lock with a scalable key management system. How do we make sure that locks and keys give users the experience that they expect, the seamless transparency and agility of the business application, the whole reason they went to the cloud in the first place? And I'm going to hand it back to Jerry to take a further examination of that.
Thanks, Jeremy. At this point, I'd like to transition to David Stott from PerspecSys. PerspecSys is a leading software company that develops cloud data protection gateway solutions that are used by enterprises to secure sensitive data before it leaves their control and enters cloud environments. As Senior Director of Product Management, David is responsible for defining and executing PerspecSys' product strategy. He brings over 20 years of product management and product marketing expertise from companies such as Coverity, Angos, ADP, and Ironside Technologies. He's an active member of the industry associations such as Cloud Security Alliance, the International Association of Privacy Professionals, and the Canadian Cloud Council. David, it's all yours.
Thanks, Jerry. Hello, everyone. Before I begin, I want to reflect a little bit on the report that John Howie shared regarding the top threats in the cloud, and specifically segue from Jeremy's comments on looking at some of the operational challenges in encrypting data, considering a public cloud or a SaaS environment. What I want to do in my section is really drill down into some very tactical operational detail for the audience today in the event that, again, there's folks on the line that are potentially evaluating solutions to protect public cloud applications. Before I begin, I want to reflect a little bit on ways in which cloud data protection is both like and unlike other data protection domains. So first of all, obviously, a lot of the security operations aspects of cloud data protection is very much like data protection in other domains. So certainly key management best practices and standards are an area that would be obviously like or ought to be like data protection domains. So that refers to obviously the generation, the security of the key material, the rotation, the cryptographic periods, etc. Obviously, if your organization is classifying data in terms of sensitivity levels, whether the data is located, for example, in an on-premise system or a cloud-based server, again, the data classification is still the same. If anything, cloud might complicate or require more rigor in terms of your classification approaches. And also similarly, if there are compliance requirements that your organization is subject to, for example, industry-specific requirements around healthcare, banking, etc., obviously the location of the data in the cloud may be germane to those requirements and may require some additional consideration. When we think about the way that cloud data protection is unlike other data protection domains, and here again we're going to focus on public cloud and specifically SaaS, there's really a few pivotal kind of cruxes or pivot points that the audience we really should be focusing on. One of them is that the data residency tends to become potentially a new issue. Data residency, again, the issue here is my cloud provider may be in a jurisdiction outside of my own jurisdiction, and the country I'm in or the business that I'm working in may require that data persist or be stored in a certain physical location. Data residency, data sovereignty is probably a topic unto itself, but needless to say that data controls within a public cloud environment may require we evaluate data residency impacts based on our location, right? What I want to focus on really are the next 2 points. When we think about how we do it operationally, I want to first segue from Jeremy's discussion around format preserving encryption, talk about format preservation. In an environment like a public cloud application, CRM system or human capital management system, if the data is encrypted in a certain way, oftentimes the length of the data will create problems because we don't control the data model, right? The cloud service provider controls the field lengths, sometimes the format of those fields. And so having data protected while preserving format is critically important. And secondly, and another area we're going to go into more detail on is, again, the way in which application functionality is preserved becomes critical, right? So unlike encrypting data, for example, that's simply stored in a block storage, and it's simply meant to be protected and sort of kept safe, data in a public cloud SaaS application is typically in an operational system. So our users are potentially in a call center or in sales and marketing, or that's potentially part of an internal business operation like human capital management or HR, where we're actively working on that data that's potentially part of an encryption policy, right? So that data needs to be protected, but also needs to be usable. In other words, the users need to be able to take full advantage of the application functionality. And that could include functionality like be able to sort lists, be able to conduct different types of searches, be able to run reports and export data, etc. And really, to think about the data protection requirements, I'm going to say, I hate to use the word colliding with, but intersecting with the application functionality, this is really a defining way in which we need to evaluate these types of solutions. So what I want to talk about now are 2 different approaches that tend to be prevalent on the market. So if the audience will forgive me a little bit of creative license, the first method I'm going to describe is what I'm referring to here as a Seesaw Method. Right? The Seesaw Method really describes the paradigm in 2 dimensions. Right? So the 2 dimensions really here are strong security and application functionality. And what tends to happen in these solutions is that if you require strong security, i.e., a vetted algorithm of the caliber that Jeremy described, what will happen is that application functionality will tend to be eroded or compromised or limited in some way, right? So, for example, on the converse, if you want a certain application feature to work or functionality to be preserved, you're required to use a specific obfuscation technique, right? So the example out here is, if you want to search application data that's potentially encrypted in a SaaS application, you may need to use a proprietary algorithm that would generally represent a weakened security posture, right? And conversely, if you require a specific obfuscation strength or approach, you might be limited in functionality, right? And this is really important specifically to organizations that are subject to industry requirements that specify that a specific strength of encryption must be used for certain types of data, right? An example would be organizations that are subject to ITAR, where, again, the guidance specifies that only FIPS 140-2 cryptographic module certified to either level 1 or above strength can be used. In these cases, using these modules would, in the so-called Seesaw approach, would tend to limit, compromise, or break application functionality, right? So you can clearly see that the organization needs to make a trade-off with this approach. And I want to kind of bring some color to show you exactly how this operates behind the scenes. So again, for those who might be part of security organizations that are on the call today, just a quick slide here to highlight what this method actually introduces. So the rise of this class of solutions has introduced a new term which may be familiar to some of you, called operation preserving encryption or function preserving encryption. This is a method of data obfuscation, like I described, that it definitely masks data, but you will see that for it to function, basically its purpose is to allow functionality like search to still function even when it's applied. And it's applied with obviously a pattern that eliminates randomness and is to a certain extent deterministic in its output. The example we have here on the screen shows that I've got Smith as examples only, Smith, Smithsonian, and Smithereens. And you'll notice that the ciphertext all has a similar character pattern, right? And that's designed that way on purpose so that if a user was able to, for example, type a search like starts with Smith or starts with SMIT as an example, and if I was to encrypt that search term and send it on its merry way to the cloud, what happens is I will be able to find Smith, Smithsonian, and Smithereens by virtue of the fact that we've preserved the ciphertext with a very specific pattern, right? So they all have the same set of characters. Again, if you're in a security organization, I would encourage you to evaluate whether or not this would really satisfy your security requirements. So, the question becomes, okay, so what other options exist if this isn't more than a two-dimensional requirement? Let's talk about another approach, right? The second approach we have is, okay, so under what conditions or how is it we can go about using a strong encryption, using algorithms vetted to this strength that Jeremy described earlier, and not impact the application functionality for which the SaaS application really was designed to support in the first place, right? And that's really, the approach there is to really bring some intelligence into the gateway provider. So the cloud encryption gateway provider would introduce new services that would allow you to use whatever cryptographic solution you wanted. You may have existing relationships and expertise with a particular cryptographic provider, so you can use whatever security strength you need while preserving application functionality of the caliber of searching and sorting, etc. And this is done by introducing a third variable, again, which is some additional intelligence or horsepower, if you will, in the gateway itself, right? And this, again, allows you to not be forced to make these types of unfortunate trade-offs between security and functionality, which tend to be, unfortunately, kind of lose-lose propositions. So if we just bring it back to above and beyond functionality preservation when you're encrypting data, there is still this matter of format preservation, right? So it's, again, as Jeremy outlined, it's not enough to simply preserve application functionality, but you have to do it in a way that oftentimes controls the way in which the ciphertext presents itself to the SaaS application so it can be properly processed. This can be, there's really two critical things here. If any of you are familiar with the way SaaS systems work, the lengths are typically limited by the provider, right? The field lengths. If a field can only be 40 characters, it can only be 40 characters. And in many cases, there is high value in validation done to ensure that the format of certain input fields meets a structure, like a social security number or dates, etc. Right? So this is kind of, again, part and parcel of the value of that SaaS application. So again, how would we go about applying strong encryption, vetted encryption, and preserving the format of the ciphertext to allow my SaaS system to still work as it would expect? And the method there is to use a NIST-approved FFX mode. That's the format preserving encryption cryptographic solution that Jeremy talked about in your encryption gateway. So the combination of a format preserving encryption with a gateway that allows you to introduce those types of modules would allow an organization to obviously ensure that the data that was being encrypted was protected to the degree that they required, and all of the format aspects, whether that was a length issue or whether it was an issue related to the, again, a structure of data, all of that could be preserved, right? Okay, so I've got one quick case study I want to talk through that really kind of combines, all of everything we've been talking about on the webinar today. So, obviously, thematically, John Howie's comments around the threats, Jeremy's discussion around the importance of data-centric security and format-preserving encryption, and then some of those practices we talked about with specific regard to cloud encryption gateways. In this case, obviously, being in a security space, we're not going to name the company that was involved, but we're working here with a Global 100 financial services organization. Right? Their challenges really were twofold. One of them was strong internal compliance requirements to introduce additional security measures to protect data based on an internal sensitivity rating when adopting cloud applications. And I would say, obviously, an interesting dimension here was that there were potentially very large cloud deployments. So the company here wanted to, again, take full advantage of cloud to scale their business operations, et cetera. And this is obviously an interesting dimension. Right? From a technical consideration perspective, again, there was multiple applications that were potentially part of this ecosystem. So it wasn't just a single cloud solution. And the organization had an existing operational expertise and an investment using a very particular cryptographic solution. That was the solution provided by Voltage. So again, if you think about the parts of the model we've been discussing, the solution approach here for this organization was to make full use of that Voltage cryptographic module that would allow the organization to make use of format-preserving encryption operations and key management. So we didn't touch today on key management in my part of the discussion. However, being able to leverage key management practices by leveraging those modules is important, obviously important, even in the cloud domain. And to do so, they basically use that Voltage cryptographic module inside of the PerspecSys gateway, right, for cloud data protection. Just to kind of aggregate the key benefits, there were really three. So the organization was able to meet their compliance requirements by adopting the public cloud by leveraging solid, well-vetted cryptographic approaches. The format-preserving encryption meant that all of their the deployment didn't have any data operational challenges in working with the cloud. The organization was able to adopt the cloud while still the end-user community was able to have an unhindered experience in making use of the application functionality. And operationally, the organization was able to use the same operational best practices around key management, et cetera, and that was an important consideration just from an ongoing cost of operations. Right? So one quick diagram just to kind of show that whole solution kind of put together. The organization has then their enterprise and their remote workers able to connect to multiple cloud applications by way of this sort of transparent cloud data protection gateway. And that gateway then extends the use of the Voltage cryptographic solution for format-preserving encryption, again, already being used inside of the organization now for this additional field of use. So the organization was able to leverage that cryptographic solution inside the gateway. All the communication to the cloud is intercepted by the PerspecSys solution, again, behind the scenes, unbeknownst to the end user. And the policy that's been described by the IT organization, the security organization, then is enforced in the gateway so that any sensitive data is protected before it leaves the organization's control. So with that, I want to pass it back to Jerry Grealish.
Thanks, David. Just to go back to the key takeaways that we discussed at the beginning of the webinar, the hope that the team has is that the discussion today sheds some light on the major security concerns that organizations have regarding cloud computing. And through the discussion with Jeremy and David in particular, the goal was to highlight some benefits that encryption at the field level within the SaaS layer of the cloud, when properly implemented, can bring to enterprises and public sector organizations that are wrestling with the idea of putting sensitive information out in cloud environments. And again, the focus, just to go back to the recap discussion, the focus for the encryption should really be on understanding the strength of the core algorithms that are being put into the environment, and do they give the security that the organization requires, as well as the usability implications for the users of the cloud application. What are the usability implications of the encryption that is being deployed in the cloud environment? So thanks to those that have been putting questions in throughout the webinar. We've got a number that have come in. What I'll do is I will go ahead and just send these out or hand these out to the presenters based on the area of expertise that they have. David, I'm actually going to go to you first here because one of the questions, actually it's coming from a couple folks, is around the technology you just described, these cloud encryption or cloud data protection gateways. And the question was about verticals or sectors where you're seeing the most interest in using these sort of technologies.
That's a good question. Thanks, Jerry. I would say that, and this probably makes a lot of sense to the folks on the webinar today, that we tend to see interest really in regulated sectors. So for us, that would include organizations, for example, in public sector, governments of different levels, municipalities, states, et cetera, national levels of government, healthcare, financial services, manufacturing. Again, we talked about ITAR, specific kind of manufacturing area, et cetera. So it really, where there are, the combination of those privacy compliance requirements. And then the other area I think we didn't touch on today, but again, another topic is organizations that are in specific geographies where, again, data residency creates potentially a barrier to public cloud.
All right, great. Thanks, David. John, I think this one is going to be for you. The attendee is asking about, so you shared some research results. They're asking about upcoming research release dates from the CSA. So what sort of stuff are you guys working on now?
Yeah, that's a great question. One of the focuses that we have is to continually update and refresh the existing research that we've pushed out there. So it's not as though we publish and then move on and do something different and let the old stuff go stale. So we are working on some refreshes of existing content. The Cloud Controls Matrix, which is part of the GRC stack, we're about to release version 3, which is a very comprehensive update. Version 1.4 was released at CSA Summit at RSA Congress and included mappings for SysTrust principles for auditors doing SOC 2 Type 2 audits. CCM v3, and we made a conscious decision to massively up the number, is going to be aligned with security guidance and some other collateral that we've released recently. You can look forward to some forthcoming documentation and guidance for small and mid-sized enterprises and businesses, as well as publications for cloud audits, Cloud Trust Protocol, some more big data stuff. In fact, we just released some more big data guidance. More mobile work. So it's mainly a case of refreshing our existing intellectual property and then pushing out some new content as well. But this year is going to be a very busy year for us. Go to our website, click on research, and you'll be able to view the coming research calendar.
Okay, great. Thank you, John. Jeremy, I got a couple of questions that have come in around FIPS certification compliance. And the question is really, if I look at them combined, it's around the relevance of those sort of certifications. Is it really a U.S.-focused thing? Is it strictly important only in the U.S., or is it important in other regions? And if it is just U.S., is it a government-only thing, or does it apply to other sectors as well?
Yeah, that's a great question. Standards become useful the broader they're adopted. If anyone's ever traveled overseas and tried to plug a U.S. plug into 220-volt European wiring in cryptography, that the entire world has looked to NIST as the single authoritative de facto agency for validating and vetting cryptography. And that's really been a 30 or 40-year process, but NIST is now the authoritative source on how to establish standardized and accepted, vetted, and validated cryptography. NIST writes the FIPS standards. FIPS defines a ton of other things, by the way. FIPS defines sort of standard formats for dates and other things that the government needs in information processing. But as it relates to cryptography, all of the international bodies, the European Union, Japan, Asian markets, have all really followed the lead and sort of authoritative work taken place inside of NIST. So the short answer there is we have one standard recognized around the world as authoritative on cryptography, and that is NIST. And NIST writes the FIPS guidelines for the U.S. government, and those are followed in Canada, Europe, and Asia as well.
Okay. All right. Thank you, Jeremy. Had a couple questions that have come in around the availability of the presentation. After the webinar completes, we'll send out an email within a day that has a link that the attendees will be able to download and have access to the presentation and the webinar. Jeremy, actually another one for you regarding format preserving encryption. The attendee is asking, is it strictly for data types such as credit card numbers, dates, etc., or is it more generally applicable?
So the power of format preserving encryption is that you can define the output alphabet. And so in general, highly structured data elements, dates, fields that connote information, social security numbers, driver's licenses, the LUM checksum in a credit card, can all be defined as alphabet-specific results in format preserving encryption. We do see customers from consistency standpoint to use format preserving encryption for larger data sets, and we do support that. You can drive a general purpose encryption through format preserving encryption. So the short answer there is yes, it is flexible to support that. But the real power comes in I guess the unique differentiation comes in the format preservation, field length preservation for certain data elements that may show up there. So address fields is a great example. Inside Salesforce, the database has a fixed field length for address fields. And so we can guarantee with FPE that we're never going to blow through the field length size of an address field when we encrypt it with FPE. But that's a great question.
Okay, thanks, Jeremy. John, actually, one for you that I'd like to get your perspective on. Two related questions. The idea is basically, do you, in the CSA, based upon the survey results, do you see regional differences? So, for instance, are you seeing the U.S. further along in deploying some of these techniques on encryption versus Europe, or vice versa? Or is everybody pretty much in the same level of maturity in terms of adoption?
Good question. We haven't really done an analysis on who's using tools such as encryption on a regional level or regional basis. However, I would say that certainly interest in encryption is driven by statutory and regulatory compliance obligations. So if you're in an industry sector, or if you're in a jurisdiction that may require encryption or has some rules or laws which can be addressed or compliance can be met through encryption, then certainly we will see a higher level of adoption of use of encryption. So while we haven't done a breakdown by region or geography, I would speculate, and it's probably accurate as well, that if you're living in one of those geographical areas where there's a lot of laws around privacy and security of data, then the chances are encryption use will be much higher.
Okay. Could be a topic for some future research, perhaps. So actually, I think we have time for about one more here. David, I'm going to go ahead and give this to you because it's a question about how enterprises have multiple security layers, and you described a gateway technology that intercepts information going out to the cloud. There's also technologies that are used to control access to cloud-based applications like single sign-on. So how do these gateways work together?
Thanks, Jerry. I think it's a critical consideration if people in the call today are evaluating these solutions, that obviously they must interoperate, right? So if an organization is already leveraging a single sign-on solution, for example, to control access to public cloud, right? So centralizing control of identities and access rights. Naturally, this needs to work in concert with solutions that control the data level. So having, in any way, have the data level controls, for example, an encryption gateway, interfere with the benefits of the single sign-on solution would be obviously would not be acceptable. So we, PerspecSys, our position, we view these as highly complementary, and obviously a hallmark of our solution that these are able to interoperate. So.
Great. Thanks, David. And there are a number of questions that we were not able to get to in the time. As promised, I'll make sure that we follow up independently with each of the folks that we didn't get to and get back to you with answers on those. Again, we'll be sending out an email with a copy of today's slides, a link to them. I want to thank all of the attendees for joining us today, and a special thank you to David and Jeremy and John.